This is section 7.6. We're solving systems of linear inequalities, and we have a couple of goals. First one we're going to look at today is solving a system by graphing. Next one we'll look at tomorrow, both writing systems of inequalities and modeling real life situations. First thing we have is the definition of a system of linear inequalities. Just like a system of linear equations, it's two or more inequalities, this time in the same variable form, or simply a system, just a system of linear inequalities. Two or more inequalities written. So y is less than 2x plus 1, and y is greater than or equal to half x plus 3 would be a system of linear inequalities. A solution of the system of linear inequalities. Solution in two variables x and y is an ordered pair that satisfies each inequality in the system. So if we were to graph two inequalities and one looked like this, showing everything shaded this way, and the other one looked like this, showing everything shaded this way, the solution of them is the area that they overlap, and we'll look more at that in a second. But the only overlapping area is this area here. All of this area here is where they overlap. Anything that falls in the other sections will only satisfy one or none of the two inequalities. Only the black area as it is up here will satisfy or make both of them true. And that would be a graph of the system. I actually put the wrong example for it. That's what I meant to put for that one. But again, it's a point that falls inside of that picture or inside of that graph that'll make them true. First example is a triangular solution region. Notice you're given three inequalities. Y is greater than or equal to -3. Remember, greater than or equal to means a solid line. Less than, x is less than 2, that's a dashed line, and y is less than x plus 1. What you want to do is you want to graph all three inequalities on your picture. So the first one, y is greater than or equal to -3. This is your y-axis here. So where -3 is, you want a solid line. That's this one here, a solid line, because it's greater than or equal to. And you want to shade everything above. Watch how messy it's going to get. You want to shade everything above. You can even do it real small like that line. The next inequality is x is less than 2. Notice that says less than. That's where this is your x-axis here. You want a dashed line on this one right here at x is less than 2. Less than 2, we know that smaller numbers are this way on less than 2. Again, you can shade it real small like that to where you don't see a whole lot of mess. Everything that way is smaller than 2. And then the last one, x is less than, I'm sorry, y is less than x plus 1. Your b value is 1, so you need to start at 1. Your m value is not shown, but it's the one that's in front of the x. It has to be over 1. So you go up 1 and over 1 for your second point. And since it's less than and not or equal to, that's why it is a dashed line. Now at this point, you can't just guess. You can't just put left or right or up and down like we did on the other two. You have to actually check the truth value. You can plug in 0, 0 because it's not going through that point. So if we look just at this equation here, when we plug in 0 in place of y is less than 0 in place of x plus 1, 0 is less than 1. That's a true statement. That means everything on the 0, 0 side or everything on this side is true. So the only area that all three of the inequalities share in common is this area that was shaded when we first looked at it, this triangle that's on the inside. This is the area that they share in common, all of this area here. Notice in that bubble off to the left, it says to check your gap, choose the point in the overlap of the half planes. Then substitute one of the points to see if it gives you a true statement. The easiest point, again, the easiest one to pick is 0, 0. So we can choose that point again, 0, 0, because it's not on any of the lines. And it's the easiest thing that when we multiply 0 by anything, it gives us true statements. Check that first equation. 0 is greater than or equal to negative 3. True statement. The second equation, 0 is less than 2. True statement. And we checked the black one already. We plugged in 0, 0, and we got 0 is less than 1. So all three of them are true, and that's why it's a solution. Example number 2 says, write a system of inequalities that defines the shaded region at the right. We'll actually come back to this one tomorrow. I want to go a little bit past this for right now. Same thing with example number 3. Let's look at checkpoint number 1. It says, graph the system of linear inequalities. Both of these are inequalities that are in slope-intercept form, mx plus b. So your first inequality, if we look at it, your b value would be 2, and your m value would be 2, which is over 1. So if I'm going to show you the one that's drawn for you, but I want to do them individually real quick where people don't jump too fast to it. So your b value, remember that's your y-axis. Your b value tells you to start at 2. So begin here. Then it also tells you to go up to and over 1. So up to and over 1, that's your second point. So it says less than, not, or equal to, so a dashed line. Then check the truth value to see which side you're going to shade. We can plug in 0, 0. So 0 is less than anything times 0 is 0 plus 2. 0 is less than 2. That's a true statement. So everything to this side of it. Everything to that side. Notice I shaded it real small where it won't make a big mess. But everything to that side. The second inequality, your b value is negative 1, and your m value is negative 1 over 2. So begin at negative 1. M tells you to go down 1 and over 2 for your second point. And again, that's greater than, not, or equal to. So a dashed line, that would look like so. And then check the truth value. 0 is greater than negative, anything times 0 would be 0 minus 1. 0 is greater than negative 1. That's true as well. So everything on this side, the same side as the 0, 0 side. So the area that they have in common, the overlapping area, would be everything in this area here. And again, this extends infinitely this way and this way, everybody. Everything, that means any point that you plug in that area will make both of the inequalities true. And this is what it would look like a little bit neater. But notice it looks a whole lot like the picture that I have drawn, just a little bit neater. And that's where we'll stop today. We'll do the other portion tomorrow.